Hello viewers, let me welcome to this session of discussion. Today we will discuss the topic electrostatics. To begin with, electrostatic, as the name indicates, it is the study of physics when the charges are at rest. To begin with, let us see what is electric charge, how many kinds, how do they exist, what is the type of interaction, what is their nature, what are the experimental evidences to experience their presence. As you all know, the matter around us is consisting of molecules, and molecules are consisting of atoms. For example, an argon molecule contains one atom, so it is monatomic. Hydrogen molecule contains two atoms, so it is diatomic, so on and so forth. With the advancement of technology and scientific research, it is observed that molecules or atoms or in general matter are composed of certain elementary particles at the fundamental level. Hundreds of elementary particles have been so far discovered, but in our present case, let us concern about the three common elementary particles: electron, proton and neutron. These particles are elementary in the sense these are not composed of any other particle. Now the mass of these particles are given. Mass of the electron is Me is equal to 9.1 10 131 kg. You can use. Mass of the proton is 1.672 10 127 kg. Similarly, mass of the proton is given. And if you want to compare the mass of the proton that of the mass of the electron, that is MP by Me, it is coming as 1836 on a level 2000. That is MP is 2000 times Me. That is MP is much greater than Me. But the mass of the proton seems to be little bit larger than the mass of the seems to be less than the mass of the neutron. But the difference Me minus MP cosmos in nuclear physics. Force of interaction, let us see, since the elementary particles possess mass, how do they interact? And you know, mass interacts with another mass with a force called gravitational force, and the formula to calculate the gravitational force is given by Fg is equal to G m1 m2 by m1 by r square, and G is equal to 6.67 by 10 to the minus 11 Newton meter square by kg square, and in the CG system it is 6.67 to the minus 8 dyne centimeter square by gram square. Now using this formula, let us see what is the gravitational force of interaction between electron and electron, and we have to use the formula given by Fg is equal to G m1 m2 by r square, and for our electron system, let us assume that the distance of separation is 1 cm to the minus 2 meter, and the intervening medium is air or HU. So Fg is equal to G me by r square, G me square by r square. That is substituting the values, it is coming as 5.53 into 10 to the minus 67 Newton. Similarly, let us calculate the gravitational force of attraction between proton and proton at the same distance apart near a vacuum, and is related to be Fg dash is equal to G mp square by r square, 6.67 10 to the minus 11, and the values are substituted, and it is coming as 1.866 10 to the minus 16 Newton. And the electron proton system the same distance apart, the force of attraction is coming as 10 to the minus of the order of 10 to the minus 63 Newton. So if you look at the forces, these forces are very, very weak, and gravitational force of interaction is generally a weak force. Now, however, it is observed that these elementary particles like electron, proton and neutron, two electrons repel each other, two protons repel each other, and there is an attraction between electron and proton. other than gravitational force. And no such interaction exists between neutron and electron, neutron and proton, and neutron and neutron. Now the question arises, how these forces exist between these elementary particles like electron and proton. So it suggests that the electron and proton must have some additional property other than mass, by virtue of which they attract each other, they repel each other, but no such force is existing between neutron and electron, no neutron and proton, and neutron and neutron. So, see, it seems that neutron doesn't have this property, and this additional property is called electric charge. And the force due to this electric charge is called electric force, and if the particles are at rest, then this force is called electrostatic force. As the two electrons repel, as the two protons also repel, and there is attraction between electron and proton, it indicates that the nature of the charge of the electron is different from the nature of the charge of the proton. And arbitrarily it is chosen that the electron has a negative charge and the proton has positive charge. And neutron is electrical neutral because it doesn't have any charge. Or we can guess that neutron contains both positive and negative, and that makes neutron as a neutral. Since two electrons repel and two protons repel, and electron and proton, they attract each other, we can say like charge repels, unlike charge attract, and this is known as the law of electrostatics. Now the question is, what is the amount of charge that the electron has and the proton has? To know the amount of charge that the electron and proton has, we have to measure them with some proper units. And remember, the exact definition of charge may be an impossibility, just like mass, length and time. But however, we are able to measure the charge of the electron proton, and proper units are given. The unit to which the charges are given will be shown in the next video. Thanks.